All right, we're here to talk about student Luke. So, Luke, have you heard about absolute value before?
No.
Okay, so let's take a look at what it means. Really, it's just the distance from 0 on the number line. So let's look at a number line here, and let's put 2 points here. One is 3, and one is -3. How far is 3 from 0?
3.
Yeah. How far is -3 from 0?
3.
Yeah. So when we do absolute value, we put so the absolute value of 3 and -3 is the same. It's 3. And when we write it in math, we don't have to write out the whole word absolute value. It's much easier. You just put these straight up and down lines around it. So this we read as the absolute value of 3. Okay? And this we read as the absolute value of -3. And what are both of those things equal?
3.
Yep. Okay, so you see how this math statement is true?
Yeah.
Okay, good. Now, let's look at a couple of other examples and see if you get the idea. What's the absolute value of 103?
103.
Very good. Pretty simple, huh?
Yeah.
What's the absolute value of -3.2?
3.2.
Yep, you got it. So now it seems so simple, you think like, why in the world should I care? Well, actually, absolute value is used in the real world, and it helps you to talk about some real world situations. So let's go ahead and, on the right-hand side here, let's go ahead and talk about a couple of those. Okay, so let's read this together. An inventor is experimenting with 2 kinds of freezing machines. Her goal is to get a machine that creates a temperature as close to 0 degrees as possible. Machine A creates a temperature of -3 degrees, and machine B creates a temperature of 2 degrees. Which machine is closer to the inventor's goal? So how would you think about this?
Well, the absolute value is 3 of -3 is 3.
Yeah.
So that's more than the absolute value of 2, which is 2. So machine B is closer.
Very good. So we think about this in terms of absolute value. You're absolutely right. Absolutely right. The absolute value of machine A is 3. Machine B is 2. And absolute value is a great way to think about this because she wants something as close to 0 as possible. So she wants the least absolute value, right? Good. Okay, let's just look at one more situation. Yeah, so machine B is closest to the goal. All right, so one winter day, the temperature in Buffalo, New York is -22 degrees. Pretty cold day. And the temperature in Anchorage, Alaska is -10 degrees. Also really cold. So I'm going to ask 2 questions here, okay? Where is the temperature greater and where is it colder? Okay, so let's take that first question first. Where is the temperature greater? And remember, when we talk about greater or less than, we're talking about to the right on the number line or to the left. So which temperature is greater?
-10.
-10. Okay, now that might seem strange to call it greater because it doesn't feel like as big a number as -22.
Yeah.
But really, greater than and less than are all about position on the number line. So the greater temperature, it's warmer in Anchorage, Alaska, right?
Yeah.
Okay. Now, where is it colder?
Buffalo, New York.
And we could say one reason we could say that is the coldest number, the biggest cold number, is the most negative number, or the one that's furthest away from 0.
Yeah.
Right? So that's kind of like the absolute value. So it's colder in Buffalo because Buffalo has the greater absolute value. Make sense?
Yeah.
Okay, great. Good job.